All right. Hello, everybody. Happy Thursday. Welcome to the webinar today. I'm Tom. I'm the applications lead here at Voltera. And today we're going to be talking about printed electronics using silver conductive inks. So on today's agenda, we're going to do a quick overview about Voltera and all of our dispensing systems. Next up will be Dr. Rudy Ghosh from NovaCentrix, who's going to give an overview of his company and a presentation about conductive inks. Once Dr. Ghosh has finished up his presentation, we're going to open up the floor to questions from the audience. Just ask your questions using the Q&A button located in the Zoom control bar. And the more upvotes that a question has, the more likely we are to see it and to prioritize it for answering. And just two more things to mention. The V1 is currently on sale for $800 off. And if you wait until the end of the webinar, there will be a $2,000 coupon code towards any purchase of Nova. First, we're going to talk a little bit about us, Voltera. We're a company founded in 2013, and we're on a mission to drive change in the additive electronics industry by catalyzing innovation by removing the barriers to entry. We have two main products, the V1, a desktop printer for prototyping traditional PCBs, and Nova, which specializes in printing and prototyping flexible and stretchable electronics. So, as mentioned, our first product that we're going to talk about today is V1 and how quickly it can bring your electronics ideas to life. The V1 was designed for prototyping electronics in a more traditional sense, focusing on rigid substrates, typically using FR4 or FR1. Printing your designs is as easy as uploading your Gerber files, probing your substrate, and then pressing print. The V1 also has a built-in heated bed, so you can cure your prints right at your workbench. It can achieve traces of 200 microns, and it can handle up to 0.65 pin-to-pin pitch for your components. After you've printed your circuit, you can cure right on the print bed, and you don't have to leave your desk. In addition to printing and curing the circuit for your PCB, you're also able to dispense solder paste all the way down to 0402 pads with a pin-to-pin pitch of 0.5 millimeters. It will also allow you to reflow and then at 190, and then you can also do hand soldering. Although if you'd like to hand solder, I recommend reading our support docs on the best ways to approach this. As mentioned, you can use the machine to reflow. The machine does heat up to 240 degrees. The solder paste that we supply reflows at 190, but if you want it to go hotter than that, that is always an option. The V1 also comes with a drill attachment, so if you wanted to do more complex designs that are double-sided, you're able to drill vias and print on both sides of the circuit board, and then put copper rivets through in order to make that connection from the top to the bottom layers. If you have any more questions about the V1 or how it can help you, feel free to ask in the Q&A or reach out to us at sales@voltera.io. Next, we're going to talk about Nova, our most recent product. Nova was built to fulfill the needs of developers, researchers, and people in the industry who loved the V1 but wanted more from it than what we had originally intended it to do. This led to the development of Nova. It's a dispensing system with the ability to print on a wide variety of different substrates, such as PET or TPU, and with a wide variety of different materials like gold, silver, copper, silver chloride, graphene. The list goes on and on and on. It can be used in a variety of different applications. It has been used in a variety of different applications and is compatible with just about any screen printable ink you can find. On our website, you can find a variety of different applications that Nova has been used for. And just for a couple of examples I've listed here, we have done a 4-layer electroluminescent display using a blue phosphor ink, biocompatible EKG dry electrodes printed with gold, stretchable silver ink that we've printed directly onto fabric to make some heated up mittens for our frigid Canadian winters, and a printed battery, which consisted of 7 layers and a variety of different materials. And then we've also introduced a semi-automated calibration procedure. One of the biggest challenges with bringing in a new ink to a system like this is getting the best print quality that you can. It can take days or weeks to really fine tune. So what we've done is we've developed a semi-automated calibration procedure, which lets you iterate through different settings without needing to know all the ins and outs of the software or the ink. It allows you to tell the software what is wrong with your current quality of print, and then the system will adjust settings and you can continue to iterate through that until you're satisfied with your results. The settings for your materials can then be saved and reused whenever you want when you're printing. Another feature that Nova includes is a vacuum bed. It is made of smooth porous titanium, and it lets you hold down any flat, flexible, or stretchable materials that you might want, such as PET, Kapton, or TPU, utilizing a built-in vacuum pump. If you're looking to print on a rigid substrate such as FR1 or maybe glass or anything that you really need to clamp down, there's a M5 a grid of M5 threaded holes underneath of the vacuum bed that you can pop off and actually mount directly to the base of Nova. If you have a jig that you've designed to custom hold some kind of weird shaped substrate, that is definitely available to do. The last thing that I wanted to touch on about Nova today is our newest software feature called Plan. Plan allows you to load your design files all at the same time into the system and really fine-tune your prints. It allows you to edit toolpaths, place probe points, and really plan out a print from start to finish. The most exciting thing, though, I think for me at least, is that it allows you to print multi-layer PCBs. It allows you to do this in one continuous workflow once everything has been set up, and all you have to do is follow the on-screen instructions, and you'll be developing and prototyping your own multi-layer circuits in no time. That concludes our brief introduction to Voltera and our products. If you have any questions, again, feel free to drop them in the Q&A section or reach out to us at sales@voltera.io. And now, I am pleased to introduce Dr. Rudy Ghosh, the VP of Business and Application Development at NovaCentrix. Take it away, Rudy.
Thank you, Tom. Can everyone hear me clearly?
Loud and clear.
Okay, that's always the first task to be accomplished for any webinar or Zoom meeting, right? Let me share my screen before I start talking. But what I would really like to also thank, one of the things I think we need to kind of highlight is the long relationship that we have had with Voltera. I remember meeting the Voltera team first at either 2016 or 2017 LOPEC, and since then we have worked together for a long time. Let's send request. Yeah, and it has been a very, very productive and very collaborative relationship, and we hope to continue this for a long time. Can my screen be seen by everybody?
It looks like it, yes.
Okay, everything is moving in the right direction. I'll move a little bit so I can see my screen as well. Okay, so first of all, I wanted to thank the Voltera team for giving us the opportunity to come and present today. For today's talk, we'll be mostly focusing on how to customize inks for very specific applications. But for today's talk, we will mostly be focusing on silver inks for direct ink applications. Before I go into the materials part itself, a quick overview of who we are. We are a materials and equipment company from Austin, Texas. If you have known us from before, there's a materials part, and in 2022 we spun off our equipment part into PulseForge, which was a tool that we use for photonic curing. We are still in the same building. We still have the same ownership structure. So if you have any questions about the photonic curing tool, that's something that we can handle as well. The only thing that I really wanted to mention, this is a technical talk, so I'm not going to go into all the business details, but we are a company with a global footprint. Last year we sent out materials to more than 40 countries in 6 continents. So no matter where you're joining in from this for this webinar, we will most likely be able to help you with your conductive inks needs. So let me move my camera just a little because my screen is being all weird. Okay. So what do we do in terms of as a company? Our main thing is to design and develop customized ink, and that ink can be of a variety of can be in a variety of different materials. Okay. When you think about conductive inks in general, sorry, give me 1 second because seems slideshow. My screen hasn't gone away, right? Just so everyone's good. Okay. So when you think about silver, whenever you're thinking about conductive inks, the material choices that we think about are usually starts with, oh, this is, 1 second, guys. Okay, this was working perfectly. Okay, so I'll stay on this screen. So whenever we think about conductive inks, we are thinking about when people first come in for conductive inks, a lot of people are coming from a background of more conventional electronics and how they are manufactured. So in that case, we are really thinking about uh, copper as a starting material, right? However, copper, the main reason people are thinking about copper is because they think of the lower cost and the conductivity. But there are certain things where copper is not maybe not necessarily the best choice because the raw material cost of copper is not necessarily the only thing that dictates the cost point, right? So for that, a lot of times silver is a much better choice, and silver provides a high conductivity, and it's also an environmentally stable material. We also have a lot of control over the different types of particle sizes and shapes that we can do. Besides silver, if you want a more economical solution while keeping the advantages of copper, we can also think about certain other material systems like silver coated copper, which which allows you to have the high performance of silver while having the economic benefits of copper. Besides that, for certain other applications, we have recently introduced our gold inks, and we can and gold ink really finds applications where inert surfaces are necessary. So for a lot of biological sensors, biocompatible equipment and devices, but also it can be thought of for certain applications in semiconductor devices. But besides that, gold is also used for a lot of aesthetic based applications. All of that being said, for today's talk, we are going to be focusing on silver. And when we think about silver, we are not necessarily just thinking of one material system itself, right? Silver is in a conductive ink. If you think about the material in it, it's only one part of it, right? So the metal can be silver, copper, gold, whatever, or depending on the application choice. But besides the material, besides the metal itself, you also have to think about the different types of particles that you can use. So, whether it's an nanoparticle based thing, whether it's a micron-sized particles or flakes. But besides that, you also have to think about the types of solvents and binders that are there. All of these together, the type of the species of metal, the type of particles, the solvent and binders, all of them put together dictate the printability of the conductive ink. And when you think about the printability, it's not just how it flows, but it's also the physical properties that dictate it, such as the viscosity, right? Besides that, we also have to think about the addition of that ink to the sort of substrates that you want. Going back to what Tom was saying earlier, you could think about printing on FR1, FR4, but you could also think about printing it on glass, on PET, on fabrics. And all of these material substrates have different physical properties. And so you have to consider those when you're designing an ink. Besides that, you also have to realize that not all inks will have the same sort of pre and post processing, which might include some sort of curing steps. So all of these together will dictate the sort of ink that is needed for a final application. So that is to bring to the point that when we are thinking about an ink, we also have to think about the way it's being printed. For today's talk, and what our work with Voltera has really uh, been around is for direct ink writing. But that is one of the ways of dispensing material. There are, you can do screen printing, you can have different types of nozzle dispensing. But for certain other applications where you need some lower viscosity material, you could think about inkjet printing, very high speed, high resolution printing with flexographic printing, some non-contact printing with aerosol jet or different other processes. Besides that, you might want to design your own ink in-house in your lab. And for that, you might need certain dispersions. If you want to talk about any of those different types of ink systems, we'll be very happy to talk about those in a different time as well. Okay, so when we think about designing an ink, it always starts with the end application, right? And when we think about the end application, there can be a variety of different parts, but they all have certain questions that we need to answer, right? So what would be the type of conductivity requirements? It's going to depend very much on the sort of current carrying capabilities that you are needed. For example, a heater versus, if you're trying to use something as a heater versus something where you're trying to do for data transfer, the conductivity requirements might be very different. They also will, that end application will also dictate the type of print resolution. Do you want sub 100 micron lines? Are most of your lines going to be very close together? The next one is obviously the substrate, and this can, this is usually a very, very crucial one, and that will kind of dictate what sort of printing processes can you do. Like, is it always going to be sheet to sheet, or is this going to be a roll to roll process? And all of these put together is going to tell you what your printing technique is going to be. So once you know your printing technique, for example, let's say you're trying to do prototyping of multiple PCB, multiple circuit boards with all different types of designs, similar to what you do with the Voltera V1 or the Nova. You need to think about the different types of requirements that you have. In those, you will for sure need a low sheet resistance. Usually, a lot of your line widths do not necessarily need to be less than 100 microns, and it has to, a lot of the times you will try to do these on flexible and low cost substrates, right? For something like that, direct ink writing is your solution. So with that in mind, we have worked with Voltera for a long time, and a couple of the inks that we have worked with them back in the day has been the HPS FG77. The HPS there stands for High Performance Silver. And the two different versions had the FG77, and I'll go a little bit more into the details of each of these two inks. The FG77 is a nanoflake based ink, so the particle sizes are much smaller. And FG57B is a micron sized flake ink. All of that to say is, after working for some time with Voltera, we realized that there might be certain improvements that are needed, and that's what gave rise to our HPS U11 ink. So HPS stands for the high performance silver. The U is for our new family of inks, the Ultra family. So what are some of these changes that we think about when we are trying to design an ink that is specifically for direct ink writing, right? So first of all, what are the things that, if you think about a dispensing process, first of all, your inks have to be well dispersed and small particles so that you can use smaller and smaller nozzle without it getting clogged. You need to have a very high metal loading. And again, that is because a high metal loading usually, not always, but usually will correlate to lower sheet resistance, but you also need high zero shear viscosity. So the high zero shear viscosity is needed so that when you actually print it, there is less spreading. So if you want to print a 100 micron line, you do not want it to spread out to 120 microns, right? So we were actually this week we were talking to a customer who uses the V1 and with one of our copper-based inks, and he was very happy that he could actually get close to 60 micron lines. So that's one of those sort of things that we need to be aware of. So how do we? So here's a quick overview of how we do that with the U11 inks, right? So the U11 inks are nanoparticle-based inks, but not only that, the nanoparticles are a lot smaller than FG77, right? The other part is what I was saying earlier. You can see the zero shear viscosity is a lot higher. So that means it allows higher aspect ratios. And besides that, there are also some changes in the chemistry that we have done that allows for a much higher conductivity at lower temperature curing. For example, you can get around a quarter of the bulk silver conductivity at 140 C. So all of those make this ink a very good choice for the direct inkwrite process. All of that being said, besides the HPS U11, which I just talked about, we have other inks that are also very well suited for and also have been worked on using the direct inkwrite process with both the V1 and the Nova. And for example, we have two other inks from the Ultra family, the U32HV, the 57B, which are also which has which has a lot of the same advantages of the U11. They both have excellent conductivity for low temperature curing. The 32 HV has very good flexibility, and the 57B, which we would actually really recommend for printing directly on fabric, etc., because of its higher polymer loading, actually has even higher flexibility. Both of these, after they're cured, are water and solvent resistant. So that really makes them a very good choice for use in lab scale. But besides that, the other two inks that I talked previously about, the 53 and FG53 and FG77, still continue to be very good choices. They both have good flexibility and good conductivity at low temperature curing. The 53 is good, is good for, I think, for at least, I'm not sure if the video that the picture that Tom showed was of the print on the fabric was with the FG53, but that is a very good choice of material. FG77, I like it a lot because if nothing else, it's very easy to clean up. If you look at some of the earlier work that we had, that was done with Voltera, we used a carbon nanoparticle based ink, and carbon is a very good choice for if you're making resistive heaters, things like it's a very good material for resistive inks for making heaters and things like that. That is also a water. It's very easy to clean up using just water, and after curing, they're very fast materials, so they are water and solvent resistant after curing. I did not want to take a lot of time and leave most of the time for Q&As. So I'm going to leave this slide up, which has our email addresses in case you have any questions that you did not get a chance for today. But again, one of the things we are at NovaCentrix that we are very proud of is not necessarily working with customers and giving them just off-the-shelf materials and conductive inks, but rather working with customers to come up with customized solution that is needed for their specific application. Tom, I think I am pretty much done with the presentation part. So if I'm very happy to take any questions that might be here. I also have Dr. Dave Pope with me here. He leads all parts of the ink formulation. So in case there is a question, a technical question that is more on the material side of the ink formulation, I'm going to have Dave jump in for those. Thank you.
Thank you, Rudy. Yeah, we'll get started with some questions
Before
here.
we start, Tom, do you want me to keep sharing the screen or
Um,
how is
I
that?
will, at the end of the presentation, I'll put the information back up on
Okay.
a slide. But I think for now we could just start presenting and start answering some of these questions. And
Okay.
while you do that, I'll tackle this first question, which is where can I access Nova software and how can I use Voltera's printing service to print my designs? So it's a two-part question. One, the Nova software comes with Nova. It is included. There's no extra fees or anything. So if you want to access Nova software, you need Nova. If you wanted a demo of Nova software, feel free to reach out to our sales team. They can walk you through a live demo of the software. And in order to use Voltera's printing service, which is something that my team handles, you go to our website and you go into the products page and you select printing service, and then you fill out the form, which will allow you to book a meeting with me, and then we can discuss your application and figure out the best way to help you out. All right, the next question we have here is, would you elaborate on how the ink was removed for iteration? I think that was in reference to the GIF that was shown for calibration. Now, the ink wasn't actually removed in that GIF. It iterates by printing a series of patterns that you then takes pictures of using the built-in camera that it has to and then you grade them and you continue on. Does Nova offer automatic dispensing or tip cleaning? It doesn't offer automatic tip cleaning. Typically the um, typically the nozzle, you have your settings dialed in, and then you don't really need to clean the tip. If you do, we usually just use a little Q-tip to do it. So for calibration, you would wipe the calibration plate yourself. It's easy to remove and wipe down, but it does not vacuum up like what might have appeared to have been happening in that GIF. Um, okay. One for you, Rudy.
Sure.
Uh, can your conductive pastes be used as gas sensing layers? Are your pastes suitable to be deposited on cotton substrates?
So the first question, I'm assuming this is a two-part question, right? The first part is the gas sensing layer, and the second part is printing on.
Onto cotton, yes.
Okay. So okay, I'll answer them in two parts. So we haven't really used the silver part as a gas sensing layer, right? Like normally what would happen is we would put an activated or a functionalized carbon layer on top. So we have carbon ink that can be deposited in a similar fashion, right? And then that carbon layer is going to be functionalized with some gas sensing material. Or, you can silver does not necessarily work for a wide variety of gases being sensed, right? So you could have different types of metal oxides deposited on the silver, which would act as your active layer. The silver would act as your signal carrying terminal. For the cotton, yes, we have printed quite a few of our different inks, including the FG57B, directly on cotton. There is some data about the washability, how many washing drying cycles. I know I have seen one of them being used for RF applications, where uh, they have done a washing drying cycle of at least 5 times that have then been that did not show a degradation or deterioration of the gain.
Okay. Um, I've got another question for you. How does silver conductive ink compare to traditional conductive materials like copper? That's a sort
So
of
this
vague
is
question, but I think there's
yeah,
a lot of areas to touch on for this
yeah,
this
yeah.
question.
This is a vague question, but this is also most likely the most common question that we get, right? So why choose one material over the other? And as I was mentioning earlier, uh, copper is when somebody's coming in from a more conventional manufacturing process, copper is the obvious choice because bulk copper is a lot less expensive than silver, right? So the price point difference becomes really that initial part of the question. And again, raw material copper is a lot inexpensive compared to silver, but raw material is only one of the components in making a conductive ink. So first of all, the price points start not being that different. But on the other hand, unless you do a lot of other processing, such as milling down or calendaring of your copper layer, copper and silver, neither of them act very similar to the bulk material, right? Like you're always trying to get them to be as close to bulk material as possible. With copper, one of the problems that and again we make copper inks, so just so you're like we are not throwing shade on anybody making copper inks, but copper ink has some certain problems, right? Like when you think of a porous network, there is a large amount of surface area, which also means there's a larger area for the copper to get oxidized from. And copper oxide is not a conductive material. So if there is a way in which you can protect the copper ink, in which if there is a way in which you can press down the copper ink so it's actually a really nicely stacked down material, copper is a really good choice. But if once you start doing those steps, you're really getting close to the price point between, the final unit price point between what you're getting from silver versus what you're getting from copper. And silver has certain advantages as being, with higher conductivity and less oxidation, etc. So again, I am not saying there is an obvious winner between the two, but there is also not an obvious reason to choose copper over silver. We like silver because the post processing steps, the easier amount of cleanup, etc., just helps us a lot more and our customers a lot more.
Very good. Yeah, I mean, everything you've said is true. Copper can be a bit trickier, even especially in direct ink writing with
Right.
the material
Right.
composition. So
Exactly
that's
right. Like as it's coming
yeah,
down,
exactly.
if the exposed tip gets the material there gets oxidized, and if you think about it, the same thing goes for other printing methods as well.
I'm gonna answer a question now from James Claypool, and I think you can probably touch on this as well. I've actually spoken with James in person, or not maybe in person, but in a meeting before. But he asked, does sustainability and environmental impact factor into the decisions around the choice of conductive materials and the application process? And I would say that's kind of application dependent and dependent on the company and the person. Ideally, everybody wants to go green. There's definitely a shift in additive electronics towards wanting greener, more sustainable practices. As we move into the future. Yeah, do you want to touch on that at all, Rudy?
Sure. Yeah. Again, and I am connected with James as well on LinkedIn, and I see the phenomenal work that his company is doing, and I absolutely think that's a very important factor to consider. And in an ideal case, that's always what you're going to do. But again, with silver, you cannot just wash it down your drain after you're done. So there are things that absolutely need to be taken into account. And if and I'm very happy to talk to James on how we can work together and collaborate on that as well.
Okay. I've got two separate questions here about printing on fabric. One from Marie O'Mahony and then one from Howlett. And they're kind of in the same vein. So I'm going to just talk very briefly about what we've done printing on fabric so far, and then we can get back to other questions. We've printed directly onto fabric. It's really going to depend on the density of the weave. Very porous fabric is much harder to do, and you're really going to want to get your ink. The polymer in your ink has to be able to withstand a significant amount of stress and elongation, because when we think of stretching, normally we are pulling in, one direction on a two-dimensional plane, maybe four, but with fabric, because it's woven, you're actually pulling in basically every direction all at the same time. So it has to be very resistant to that kind of strain and elongation stress. Um, we have had success with this. We have done it. There is in fact an application video on our website that will kind of goes over it. And if you have more questions, feel free to reach out to us on our through either sales or through the website with the contact us form. Second here. All right, I have a question for you. Do you have any experience? This is from, yeah, do you have any experience with vacuum compatible inks? I suspect this would be probably space related, but perhaps some other form of artificially created vacuum.
Um, yes and no, right? Because the and as technical people, this is usually our favorite answer, yes and no. We have printed. So once you've printed and you've properly cured the material, right? It's mostly it's mostly close to a metallic thing, right? So now the porosity, etc., of that comes into play when you're thinking about in vacuum structures. But we have used our inks. This was like maybe 6, 7 years ago when and I was a fresh applications engineer. One of the things that we did was do screen printing of our ink and curing it. And then and what they were trying to do is have these interdigitated structures, and they were being printed on fabric that was for the next generation spacesuits, right? So the idea is like as if you're up in the ISS, you walk out to do some maintenance stuff. As you're walking around, there is space dust that is being collected, right? And then you can basically put voltage and zap out the dust particles, right? So they did send it up there. It did get tested, and it did stay there for a while. And so in short, yes, we have done printing on fabric that has gone to space, so into high vacuum systems. But ultimately, it kind of really depends on the end application. Everything depends on the end application, right? So let's say if I'm doing it for a semiconductor process. So you do the prints on a silicon wafer and you really, really, really cure that material, right? Your silver at that point is very, very close to being metallic box silver. The the only thing on that I would be a little worried about outgassing is some of the polymers and binders that are there for increasing the adhesion of the material of the ink to the silicon, and that might outgas off and your adhesion might suffer. So those are certain things that we need to be a little bit aware of.
Okay. I got a question, and it is, will this recording be available as a link so I can share it with colleagues? The answer is yes. Anybody in this meeting will get a email after the webinar with a link to the recording of this webinar. It's also, you can visit our website. They will be posted on there, as well as all of our fantastic videos around V1 and Nova. So yeah, if you have
Just a plug for you guys too. It's like
yeah,
the Volterra website is one of the best
yeah.
looking / one of the best designed websites for applications and resources. So kudos to you and your team.
Well, thank you very much. Our marketing team are all rock stars, so uh, I'm sure they'll appreciate the compliment. Um, which of the U32 and U57B, I assume those are both silver inks, would you suggest? I know 57B is. Would you suggest for flexible conductive wearable sensors?
I would most likely suggest 57B. It is got a little bit more polymer loading. All of that being said, if whoever has this question, right, uh, I'm very happy if we have a discussion about your specific application and what sort of things are we trying to optimize for. If flexibility is what we are trying to optimize for, you don't have to stop at either of those two inks. We can redesign, customize an ink for you if that's what's needed. And that's really one of the, I want this to be one of the takeaways from this webinar is like we have a lot of inks that you can get off the shelf. We have a very large portfolio of inks that are for a variety of different printing techniques, variety of different materials. But what we really, really pride ourselves in is being able to work with customers to come up with uh, customized solutions that are specifically needed for that application.
All right, I'll take this next question, well, we can both do that, but can you expand more on soldering components and what is the process or materials you recommend? And I can say from personal experience, FG57B and their new ink, especially the HPSU 11, are very good for soldering. HPSU 11 is very robust. When you are soldering to additive materials, especially hand soldering, you have to
Mhm.
approach it with a different mentality than you would bulk copper, like an etched PCB, where you need to apply a gentle touch.
Right,
Um,
right.
because it is additively adhered, and while it does adhere very strongly, if you have the will and the heat, you can, you can destroy whatever you want, especially if you go much too hot, high temperatures. So we stick with low temperatures, things that are lower than typically the curing temperatures of the material or around that same ballpark. Because if your polymer cures at 180 and then you blast it with 450 degrees Celsius, you're probably going to cook it alive and maybe just make it evaporate. But Rudy,
So
you're welcome
my
to
thought on
elaborate.
that is really in addition to what you said, right? First of all, make sure before you start soldering that the ink is actually cured properly, right? So the curing is a function of the temperature and the time. So if you have to do it at a lower temperature, give it enough time so it's properly cured. The second one is uh, going back to your second point, right? Like you can obviously try to do these sort of processes with SAC 305 or lead-based ones or tin gold, tin antimony, all of those which are high temperature ones. But usually my choice of soldering material for that would be tin bismuth. If you want a
Yeah,
little bit more strength, tin bismuth with a little bit of silver.
silver.
And we recently did some studies on our inks. So if that's something that somebody wants, I think I have a paper somewhere that I can share as well.
Perfect. Well, if anybody wants that paper, feel free to
Yeah,
reach out to Rudy.
yeah.
Um, the next question is, what is the thickness of the ink after printing with Nova, and does it change after curing? I think you'll find that most conductive inks that have a solvent in them and polymer will typically shrink a little bit after curing. For Nova, I've not measured, not recently, the wet height of a printed feature, but you're looking at, without really messing around, because you can adjust the height, you can adjust the settings, you can change the features. But for the default inks that we ship with, you're looking at about 20 microns, 25 micron print height or printed feature thickness after curing. We've definitely made smaller than that and definitely made taller than that. Going bigger is usually easier than going significantly smaller, but they're all possible. Um, yeah, so yes, it's about 25 microns, and it typically does do some amount of shrinking, both vertically and a little bit horizontally, if you want to think of it that way, in when you cure. This question is, silver is flexible, right? But do you have a value of extensibility? Do you have a quick answer to that, Rudy?
Silver again, silver when it's perfectly cured and it's in its metallic state, it's not a stretchable, flexible thing. It's soft in certain cases, but it's really ultimately going to be a fact. Like as I was saying earlier during the talk, like silver is only a small part that makes a silver conductivity. Like it can have a very high silver loading, but what sort of polymers binders that you put in there is really going to dictate the stretchability, flexibility of that material. Now, if the stretchability, flexibility is way more important than the current carrying capacity, that ink can be an ink that is specifically optimized for that can be designed. So, we have done it on print. We have done direct prints on different types of fabrics, and they work perfectly fine. They can stretch. Uh, but for a lot of the shelf inks, like what I normally would suggest is printing it on TPU and then either doing a transfer. But again, we can work on getting a very stretchable ink if that is the need. I haven't looked. I am not making eye contact with Dave right now. Just so that.
Another question, can silver conductive inks be used for high frequency RF applications? We get
Yeah.
this question quite a
Right.
lot with RFIDs and antennas and people think the only thing that you're able to use is copper ink,
No.
um, which is not the case, but
Right.
yeah.
Right. In a lot of cases, silver is actually a better choice, right? Because it's especially between the inks and between the two inks, because silver usually has a higher conductivity, right? It can make better contact. So the short answer is, like, if you look for, and it's not just with our screenings, if you look for Metalon, which is the name of our family of inks, Metalon inks RF applications, I'm pretty sure you'll get dozens and dozens of academic papers on that. We not only for RF applications, for a lot of other applications in the EM space, there silver or a combination of silver and carbon, for example, for variable conductivity is something that's used a lot.
Very good. All right, here's an interesting question. I've never considered this before. Which silver ink is the most conductive, Rudy? Which one out of all of your materials? I have a guess, but
Dave, do you want to jump in on this one?
Depends on the temperature you cure at.
Right. And I think you're asking Dave which of his children are his favorite right now. So I don't know if you'll get a direct answer, but again, it ultimately depends on, it depends on not so much on the ink itself, but what is it on, right? Like, what temperature can you take it to, right? What sort of, if you take it to that temperature, are we getting rid of all the binders, etc., and therefore the adhesion is uh, is suffering. So all of that being said, the one thing that we are always constantly trying to push is higher and higher conductivity of that material at the same curing conditions, right? And that's where the U family of inks come in, right? Like, if you see, we used to have 57B, now we have a U57B, which is just changing the chemistry enough to have much higher conductivity at lower temperature. But again, if there is a specific target that somebody's trying to do, either in a given thickness or a given price point, that is something we're very happy to discuss on how we can come up with an ink solution for that.
all right, there are 2 questions left and about 5 minutes left with which to answer the 3 questions left. Okay, I'm going to answer this one, which is one of my slides has an example of the electroluminescent ink that we printed. And can I talk about the process of the exam or the process a little bit and how I did that switching between the inks? So the electroluminescent project that we did in our in the presentation is available. You can see the whole thing on our website in the application section if you navigate to electroluminescent displays. But very quickly, it was a layer of silver, a dielectric layer, a phosphor layer, and then a conductive polymer over top. And basically, it works by exciting the dielectric layer, polarizing that, which excites the phosphor layer, which then emits light when it is excited and polarized. And then another question was about IME. We have done some IME stuff in the past. Please reach out to us using the contact form. Unless you want to talk about, do you have any silver IME inks that you have in your lineup there?
We have certain stretchable inks. I do not have that sample right here, but we have done some work uh, with some of our inks which are more stretchable, have been used for IME applications.
Okay. Yeah, feel free to reach out to myself
Yeah.
or Rudy after this, and I'd be happy to talk more in depth about the IME stuff that we've done in the past. Which type of inks can we use for isolation? Do you do like insulators? Or when you say isolation, I guess, can you
Yeah, so
elaborate a bit?
I'm trying to think. There are two possible
Yeah,
answers, right? Like, if it's an encapsulant slash insulating layers, that's not something we do. Our best solution for that would be just taking, and that's what we would suggest if you really want it from us, is take the ink and we'll just take out all the metal out of it, right? And use that as our insulation layer.
yeah.
We have done that, and that works to pretty well. But then maybe this is about game shielding, if that is the question, yes, then we also have solutions for that through a combination of silver and carbon.
All right. And then what material did we deposit for the dielectric layer in the luminescent ink project? The material that we deposited, I believe, was a Ceylon dielectric ink. Again, all of the information will be in the white paper for the application projects on our website. There's a lot of cool stuff there. I highly recommend going and checking it out. It's really neat, as Rudy said. Yeah, I think that's it for questions, Rudy. I'm just gonna put up I want to say thank you to everybody today for coming.
Thank you so much.
Big thank you to Rudy for taking the time to come and talk to all of us. If you have any further questions for Voltera or NovaCentrix, you can reach out to sales@voltera.io or rudy.ghosh@novacentrix.com. I'm going to leave this slide up for a little bit. Also remember that there's a promo code. The promo code is SILVER in all capitals for $2,000 off a purchase of Nova, and contact sales@voltera for a quote. Remember to subscribe to our newsletter for any upcoming projects, industry news, deals that we're offering. And if we were not able to get to your question today, or if you need to ask a question, please feel free to reach out to us at any time. We're always happy to help. And once again, thank you so much, Rudy.
Thank you.
And I will talk to you later.
Thank you, guys. Bye-bye.
Thank you, everyone. Bye-bye.
Bye.